So now that we've analyzed and figured out how the server example worked, let's go ahead and examine the client example. So we see something similar. We see another state object, which must be used for passing the socket and buffer throughout the begin end calls. Only difference with this is the buffer size. I'm not sure why the buffer size is smaller than that, or smaller than the server size, even though same amount of data is being transferred over. We'll see. We'll see as we go down the list. We'll be storing the port, so this is going to be the constant that we'll use to connect to our application. And you guys have already seen and know what the manual reset events do, so I can skip over that. And this is going to hold the response from the server, which is similar to string content here. And like the server, but instead of resolving the host name of the current computer, this is going to resolve the host name of the remote server. So it could be your host address, it could be your host name, and then you could resolve it, or it could be the IP address directly. It could be something of that sort in order to get the address of the remote server that the client is going to connect to. And I also realize that Microsoft is using resolve for this example, even though that's deprecated, and then it should be using get host entry, I think, instead of resolve. But we'll worry about that later on. This is we're just analyzing this example. Then we create the socket that we're going to use to connect. Remember, the sockets can be used for either listening or connecting. And on this example, or on this side, we'll be using it for connecting. And then we'll call client begin connect. We'll pass our remote endpoint, the server we're going to connect to. We're going to pass our connect callback, which is down hither, and then we'll pass the client. So Microsoft, I guess they wanted to connect first before they instantiate the state object. Now, connect done, wait 1. It's going to be stuck here until connect done is signaled, saying, okay, go ahead and continue. Then it'll go to the next line. So once the connection is made, then it'll go down to send. But let's go into the connect callback first. And you guys know that there's a lot of stuff happening between the begin and the end call already. So let's go down to connect callback. Then this pass, we will get the socket from the async result. You guys have seen that before. And then we'll call inConnect. Now, inConnect does not return anything, but you would wrap this in a try catch statement, because if the connection didn't happen, then this will throw an exception. If it did happen, then it'll be fine. And as you can see here, it'll call connect done. It'll set connect done to true, basically telling it to continue. Hey, we're good to go now. Now it'll go down to send, which is the same exact thing, not basically, the same exact thing from, I don't know why I always say basically that much. Get the bytes from the string, you guys have seen this already, and then begin send. It's the same exact thing as the server. So let's head back up, and then this is calling receive after we send the data to the server after we connect it to it. So now Microsoft wants us to instantiate the state object and set the reference of the state object socket to the client, and then we'll call begin receive. Same as the server. The main difference between the server and the client is the listening and connecting part, but what happens after that is the same exact thing, just going in opposite directions. And the data might be processed a little differently depending on the side, but the packet headers would be the same, unless you're odd and you want like server this, client this, server this, client this, but the headers would be the same. But the data will be processed differently in the receive methods, but only core difference is listening, connecting, and then the rest is pretty seamless and the same in the middle. But anyway, back to analyzing this. After we call begin receive, it's pretty much the same as the server will get the state object from the async result. We'll get the client socket or our socket on this side from that state object. We'll see how much data we can read. If there is some data we can read, we'll go ahead and append it to the string builder. Again, this is basically the same thing. And then it'll get the rest of the data. Now let's see what's going on here. All the data has arrived, put it in the response. If the length is greater than 1, then response is this. Okay. Assume that all the bytes have been received. Wait a minute here. Hold up. Wait a second. So appending the bytes, just follow along with me here, guys. This is the kind of stuff you're going to be doing too if your applications start messing up or something like that. So, again, we're appending the data, okay, based on the bytes that are received, and then we'll start receiving the information. Now, if the length is greater than 1, then response, it'll set the string builder data into the response, and then set receive done to true. Now, if we go back up here, it'll write what was received, it'll shut it down, and then close it. We're missing something here. We're missing something that was in the server, unless there's something down here I'm missing? No. No. What are we missing here, guys? We're missing the check if we received all the information. I mean, sure, we sent the data off, the server made sure it received all the information, and then we sent the data back, but this is only checking if the length is 1. If we only received the 1 byte, that'd be it. And then it would continue, and if this was an actual application, our system would be screwed up, since the packet structure would already be broken. So it's little things like this that you have to be able to catch when you're working on your own applications. But we'll continue on. Then it'll set receive done. It'll say, hey, okay, we're done receiving. Continue, even though we don't know if we actually received everything. It'll write the response to the console, shut down the socket, and then close and clean it up. Let's run through it again. Just how do you miss that? Just okay. But anyways, same as before. We look at the state object. I forgot to mention this, but you guys saw this already. The class to hold our asynchronous client. And then we will have or store our port. We'll store our manual reset events. We'll have our response. We'll resolve the host name so we know who to connect to. We'll instantiate our socket for the connection. We'll connect and then freeze process our connection in here, get the socket, in connect. If there was an exception, that means the connection failed. Display what socket we're connected to based on their remote endpoint, their remote address. And then we'll signal that, hey, connection's done. Move on. Then we'll send some information and then freeze. We'll get the bytes from the string, and then we'll send it off. And in our send callback, we'll get the socket, get the bytes that have been sent. We'll display the bytes that have been sent, and then, all right, let it know that we're done sending. Then we're going to receive. We'll instantiate our state object, and then we'll set our work socket to the socket that is receiving the information. We'll call begin receive on that socket, pass in our buffer, the buffer size, our read callback, and then we'll pass the socket state object, I mean. Then we'll get the state object from the async result. We will get the socket from the state object. We'll call in receive on that socket to see how many bytes we have received. Then we will append what we received to the string builder, and we'll start receiving again in case there's more information. We'll check if all the data has arrived by apparently using the string builder. If it's greater than 1, I guess 1 byte is fine, and they just don't care since the connection is going to be shut down anyway. I'm assuming that's the reason why. If the connection's cut off, then maybe only a few bytes are going to be sent, so even though you should wait until the information is actually sent before you shut down the socket, this is why proof of concepts sometimes are a little But we'll go ahead and signal that all the information has been received. We'll display what's been received, which is probably just a T if it's done remotely. Locally, everything always works perfectly. Once you go from LAN and then you stick it on WAN, that's when you have a lot of real-world variables to take into account. But since we received everything, because the world is perfect, we'll shut down the socket, shut down sending and receiving, and then close it out. And by George, we have a server-client system. That's asynchronous.